Hello guys, for another lesson of algebra. Today we're going to be focusing on 6.1 arithmetic and geometric sequences. Okay, our vocabulary words for this lesson is arithmetic sequence, common difference, common ratio, explicit formula, geometric sequences, term of a sequence, and representation. Now, some of this information, you may already have learned this in elementary level or early middle school, but now you're going to be learning a little bit of extra information, okay, about sequences. All right, so let's go ahead and practice these problems. Let's start with the basics. We need to describe a pattern on each sequence. What are the two terms of each sequence? All right, so we notice that these numbers 5, 8, 11, and 14, we need to describe our next two terms. So from here to here is like adding 3, from here is adding 3, and from here is adding 3. So most likely, the next two values are going to be added by 3. So the next value is going to be 17, and the next value is going to be 20. Because from 14 added 3, 17, added another 3, 20. All right, so let's notice this. We have a 2.5, then we have a 5, and then 10, and then 20. So from here to here, it seems like it went times 2. From here it went times 2, and from here it went times 2. By multiplication of 2. So the next two terms is going to be a 40 and then a 80. All right. So this is what sequences means. Basically, you just find a common number that every number from the next number has the same common number, or either added, subtracted, multiplied, divided, and then you just predict the other two numbers that is going to be next. All right, let's go ahead and practice this a little bit more. We need to describe the next two terms. So from here to here is going by plus 6, and plus 6. So the two terms for this one is going to be 29 and 35 because we're adding 6. All right, let's look at this one on part B. We notice that it's been a decrease by 200, and then over here by 100, and then over here by 50. So this is not going by adding or subtracting because you need to have a common number. Basically, what's going on is that they're multiplying this by a half times a half times a half and times a half. So they're just multiplying it by half, or if you want to see it much better, they're dividing it by 2 all around it. So your next two terms, in this case, 50 divided by 2 will be 25. And then 25 divided by 2 is going to be, let's see, 2.5, I believe, 2.5. Let me see. I'm just curious enough. Calculator. So we have 25 divided by 2. Yeah, 12.5. All right. From here to here, it seems like you went -6. And then here, it kind of like added and then subtracted again. It can't be doing that. It's either adding or it's subtracting or multiplying or dividing, but it has to be with the same number. In this case, from here to here, it kind of went like times -2. From here to here, it went times -2. from here to here 1 times -2. So they're multiplying by -2. So our next two values for this one is gonna be 32 and then negative, let's say 2, 4, 64. Let's see, from here, from the 15 to the 11 is by adding the 9. We're adding 9 here. And then from the, no, sorry. I don't know why I got 9. They're adding 4. And from here to here, we're adding 4. And from here to here is adding 4. So your next two values is going to be a 1 and 5. 1 and 5. Describe a pattern in the sequence. What are the next two terms on the sequence? All right, so from here to here, it seems like it went by 6, and by 6. So the next two terms is going to be 29 and 35, and they're adding it by 6, which is letter D. Tell whether the sequence is arithmetic. If it is, what is the common difference? All right. So we have 3, 8, 13, and 18. They're going by 5s, and they're adding 5s all around it. So the sequence has a common difference of D equals 5, so it's arithmetic. Now, when we're dealing with arithmetic, it has to be added or subtracted. When we're dealing with geometric, it's multiplying or dividing. So just keep that in mind. Arithmetic is adding and subtracting, and geometric is multiplying or dividing. Now, this numbers 6, 9, 13, 17. We start out by adding the 3, and then there's a 4 plus 4 plus 4. So since the number does not have a common difference, it's not considered arithmetic. Okay, just keep that in mind. Tell whether the sequence is arithmetic. If it is, what is the common difference? So from here to here, we have plus 7. And from here to here, we have a plus 7 again. And from here to here, we have a plus 8. Since there's no common difference, it's not arithmetic sequence. Okay. Tell whether the sequence is arithmetic. If it is, what is the common difference? We already mentioned this one on the previous one. We have 7 here, 7, 8, so this is not. Let's see, from here they're adding 2, 2, and 2, so this is arithmetic. Since they're adding 2. Adding by 2. Let's see, from here to here, they subtracted 6, 6, and from here they subtracted 6. So this is also arithmetic. You could put a difference of 6. Difference of 6. You get the idea by -6. Excuse my handwriting. It's not easy to write in a tablet. Let me see if I could write it down a little bit better for you. Arithmetic. okay, by -6. Then the last one, you got 2, -2, 2, -2. Uh, it means it kind of goes like back and forth with the same number. So it means that from here to here, it multiplied by -1. From here to here by -1. Times -1, and from here times -1. So this is when, like I mentioned, whenever you're dealing with multiplication or division, this is more as a geometric. Geometric. Let's see. Geometric. I forgot the R for this one. Geometric by -1. So it's a multiplication. This is not our arithmetic. All right, which of the following is geometric sequence? Again, multiplying or dividing. So multiply or dividing. Dividing, okay? So the first one, here, they're multiplying by times 10, times 10. And it keeps multiplying by times 10, right? So there's a common ratio of 10, so the sequence is being geometric. Next one, you have 2, 4, 6, 8, 10. Let's see. It seems like they're adding 2. They're adding 2, 2, 2. So this is not a geometric, right? There is no common ratio, so the sequence is not geometric. It's more arithmetic because it's adding by 2. So here you could put in arithmetic. Okay, this is arithmetic. They're adding by 2s. 5, -5, 5, -5, 5. This is again like an example that we did here on the below on part D. And it's multiplying by -1. So this is considered a geometric. There's a common ratio of -1, so the sequence is geometric. So whether the sequence 642, 294, 2058 is geometric. If it is, what is the common ratio? All right. So from here to here, we notice that it's being divided by 7. But is this 2 divided by 7 too? Well, I mean, my bad. It's not dividing. From here to here is multiplying by 7. But let's see if this from here to here is multiplied by 7 as well. Let's use our calculator. So 42 times 7, we get 294. And then 294 times 7 again, we get 2058, which is, that's your common difference. So it's a multiplication. The sequence has a ratio of 7, so it's being geometric. It's letter B. So all of this is multiplied times 7, times 7, times 7, and keeps going. All right, so once we have learned the basics of the sequences of our arithmetic and geometric, we're gonna be focusing on explicit formulas for arithmetic sequence. This is something that you have to memorize, you have to learn it, because it's gonna basically help you in the long run to determine future numbers that it's that you're looking for a certain term that is not like the next term. You have to look for a long-term number, and you cannot be writing every single number try, let's say, find to the 100 term. Well, it's going to be a lot of numbers, a lot of paperwork, and you're just going to be, um, you might even get confused. You might get it wrong. So it's better off to know this formula so you could determine to the longest term of a certain sequence. So the n term basically is going to be your terms, either 1, 2, 3, 4. A1 represents as your first term, A2 represents as second term, A3 as third term, N represents the n term, and the D is the common difference. All right. So just keep that in mind. We have a real world scenario, and online auction works as shown below. Write an explicit formula to represent the bits as an arithmetic sequence. What is a 12-bit? Okay. Since we only have 4 bits, we don't know what's going to be the 12. And it's going to be very hard to make it information of the data. And it's going to take us a little bit of a while. So first things first, we do this as a table. We write down the bits, which is your n terms, 1 through 4. And then we have the value of the terms of every single bit. And then we got a common difference of a 10. So by using the formula on top of it, our first A1, which is your first term, is going to be 200 plus, since we're looking for n, which is the 12 bit, which is the 12 term, we put 12 and then minus 1. Our difference is going by tens, so we're going to put 10 for your D. Okay? So if you want to write this down, your A1 is going to be 200, your N is going to be 12, and your D is going to be 10. If you want to see this a little bit much clearly. So we determined we had 200 plus parentheses 11, and then we have a 10 here. We have 200 plus, then we have, let's see, 110. So let's see, 11 times 10, we have 110 plus 200. We have 310. So all of this will give us 310. And that's going to be our 12-bit at 310. That's going to be our value of the term 12. So that's why this formula is very important. So you could determine long terms for a certain value. If it's a short one, let's say find to the, let's say 5th term, 6th term, then you don't need to apply this formula. You could just figure out the difference and figure out the next sequences of the number. But if you're looking like a way long, then use this formula. All right, let's go ahead and practice this again. A subway pass has a starting value of 100. So starting value, that's going to be your A1. So your A1 is going to be at 100. After one ride, the value of the passes is 98.25. So we notice that from 100, it went down to 98.25. After 2 rides, the value is 96.50. So it went down from this to this. After 3 rides, this much. Writing an explicit formula represents the remaining value of the card as an arithmetic sequence. What is the value of the pass after 15 rights? So our n is gonna be has to be, you need to pass after 15, right? So after 15, then we're gonna have 16, no? So we have 16 rights here. All right, so we're missing our D, our difference. So 198.25. So we have 100 minus 98.25, and we ended up with 1.75 of difference. Let's write it down, 1.75. Let's see, so 98.25 and 96.50. 98.25 minus, sorry, minus 96.50. 96 and 50. Yeah, they're going by 1.75 cents different. And then we just plug it into the formula on top. We have our 100. That's your A1. So technically here is missing the 100. We could scratch it out, that one. Here you're missing information such as the n minus 1. So it's out. You're missing the n minus 1, the parentheses. Here and here, all right. This seem okay. Now, we notice that it's been decreasing the number for the next term and the next term. So it's not increasing, it's actually decreasing. So we are gonna put a minus, and then we're gonna have a 16 minus 1. Your n is 16, and then the difference is gonna be 1.75. So we have 100 minus 16 minus 1. Basically, this section is gonna be a 15 times 1.75. That's gonna give us 73.75, 73.75. So it's letter C. All right. It took us a little while, but usually if you read the information, the paragraph carefully, you analyze it, you could choose the bestest option between minus and adding. Okay, just be aware of those scenarios. Now we have the explicit formula for geometric sequence. Like I mentioned, geometric is going to be multiplying or division, and here you're dealing with multiplying. Okay, A1 again is the first term that you started, and then N is basically your terms. So this is your terms. And your R is basically the common ratio, which is what is being multiplied by for any N greater than or equal to 1. Let's go ahead and practice this. So find the explicit formula for the sequence 7, 21, 63, and 189. So from here to here, they're multiplying by 3. From here to here, they're multiplying by 3 and by 3. So technically, this is your R, the 3. So if we use your A1 is 7. A1 is 7. We just need to write down a formula, right? Yeah, just a formula. So technically you have A and equals, our first initial is 7 times your R, which is a 3 to the power of n minus 1. Technically, this is your formula for this explicit formula. Now it's telling us find the value of the fifth term. So that's going to be basically your n. So technically we have 7 times 3, and then we have 5 as your n, minus 1. 7 times 3 to the power of 4. So let's see, 7 times 3 to the power of 4. We ended up with 5, 6, 7. 5, 6, 7. That's pretty much it. You just have to practice this formula, and you should be okay. All right. Here we're dealing another type of examples. Examine the sequence of the integer below: 26, 17, 8, -1, -10, -19. All right, so let's see if it's geometric or arithmetic. From here to here, it seems like it's being subtracted by 9. And from here to here is subtracting by 9. From here to here is subtracting by 9. And yeah, everything is being subtracted by 9. So your D is going to be the difference of -9. Your A1, which is the first initial value, is 26. And we don't know our N, so we don't need to worry about that because we just need to write the expression. All right, so let's choose a different color. We have a 26, then plus n minus 1, and then our difference is going to be -9. I'll put parentheses so that way you won't get confused. This is a multiplication, not a -9, okay? So we ended up with 26. If we distribute this -9 into the parentheses, we have -9 plus 9. We just distribute this information inside. We multiply those and we get this result. We combine like terms. 26 and 9 becomes 35. Oh, I forgot the n here, sorry. And then minus 9n. So something similar that looks like that is gonna be letter D. Which expression is equal to the nth term of the sequence below? All right, let's analyze the sequence. From here to here, it seems like they're going by, they're not multiplying by 4 because we noticed from here to here it's not multiplying by 4. They're going by, let's see, going by 9s. And from here they're adding 9. And they're adding 9. So in this case, they're adding 9s. So your difference is 9. Your A1, your first initial value is 3. And we just plug it into the formula, not this formula. So we started out with 3 and minus 1, and then the difference is 9. 3 plus 9n minus 9. We just distribute the 9 inside the parentheses, then combine like terms. 3 minus 9 becomes negative 6 plus 9n, and something that looks similar to that, it's the letter H. Okay. All right. So that's all for this lesson about sequences, dealing with arithmetic and geometric. Just remember, arithmetic it's adding, subtracting, and geometric is multiplying and division. Okay. Remember that. If you have any questions, please let me know. Thank you for watching. Okay. You have a great day. Bye.